So we are now on the new unit, but let's review some concepts that you've learned. So far, we've covered how objects move. We were able to describe it, such as speed, velocity that's constant or changing. We've covered objects that are undergoing acceleration because they are speeding up or slowing down or changing direction. We've also covered uniform or constant acceleration due to gravity, which are on free fall. But we really haven't gotten into the concept of what causes an object to move. And some of you may have an idea on this. You can pause and give yourself a few seconds of thought and see what causes an object to move. So if you go back to your lab, what caused that race car to move? You probably know it did move because you apply a certain thing inside the balloon which forces it to move on the opposite end. And we're going to talk about why did it move on the other end. And that's what we're going to talk more in this particular topic. But for this lesson, your intention is to be able to just define force, be able to identify different type of forces that are contact force and non-contact force, be able to know what's the difference between contact and non-contact force. Contact force are technically a force that act at a distance, so there is no contact. It's pretty obvious with this word. So let's start with force. So if you go back to your lab on the race car that you built, you notice that the air is pushing the balloon which is connected into your car, and therefore the car and the balloon together are being pushed by the air that comes out of the balloon. Although some may not have moved, and that might be something that you would think about and what made it not move even if the air is coming out. So those are the things. So that word push gives you an idea on the definition of force. But what if the object is not in motion? Are there forces that are acting on it? And that's what we're also gonna look into as we move farther into this topic. So let's look at the definition of force, and you can pause the video and take down notes after this quick information on force that you'll hear from me. So those are the definition, and then there's one particular thing that you'll have to look into is the word interaction. Force exists because there are forces that are interacting on the object. So if you just look at your uh, toy car, your balloon powered car that you built, and you would probably notice that there are forces here that are interacting, and there is no doubt that there is more than one in here. And what are those? Those are the things that we're going to identify. Those are the things that we're going to find out as we move into the topic. And when this interaction ceases, that means they don't disappear. It's just the magnitude. The magnitude seems to be equal. Then the object no longer experience a force that would cause the object to be in motion. But one common misconception is that objects that are at rest no force exists. That is a common misconception. So we're gonna find that out as we move into our lesson. So those are a few things regarding force. So let's identify two major categories of force as described in terms of how they interact. So in a more simpler way, we'll look at the forces that are what we call contact force and non-contact force. Again, you can pause this video and take down notes as you will be asked to fill in your note-taking worksheets. So contact force are those type of force that typically are in contact. So that's the key word. When objects that are interacting are perceived to be physically are in contact, but as you get into higher sciences, that is just a perceived notion that they are physically in contact. But let's just settle with that. So any objects that are in contact are called to be interacting because they are touching each other. So these are a few examples. And we're going to talk about this as we move on. Another type of force are what we call non-contact or action at a distance. That means we or the objects that are interacting are not physically in contact with the gravitational force, for example, of the Earth. But we know that that exists, right? We are not physically in contact with electrical force, but we know it does exist. And some of you probably have felt that at some point. Another one would be magnetic force, which is kind of like related to electricity and magnetism and eventually related to gravitational. We're going to talk more about this type of forces more in detail. But most of the time you're going to be able to use this type of force that is action at distance because most of the objects that we're going to be talking are going to be on Earth. So Earth is going to be involved in this conversation. So force is a physical quantity. It is a physical quantity. Therefore, it must have a unit, just like mass, just like speed, just like velocity. It is a physical quantity in physics. So that means it exists. And its unit is in Newton, in honor of Isaac Newton, who have developed the laws of motion. So in honor of him, scientists put the unit in newtons. So if you happen to become a scientist and you get famous, they might put your last name as one of the units at some point. So we never know, right? So it is a quantity that is in metric. So we use Newton as a metric system. Its symbol is uppercase N. The symbol for force, by the way, is uppercase F. So any type of force that we're going to deal with must be written starting with F. And any type of force must be just written as a subscript. So we're going to look into that as we go on. So uppercase F and a subscript. The N is the unit. This is the physical quantity. So that's a common confusion that most students arrive at because they think this is the unit. This is the symbol for the physical quantity. The N represents Newton, which is the unit of force. Okay, so 1 Newton is the amount of force required to make a 1 kilogram mass accelerate at a rate of 1 meter per second squared, or meter per second. Thus 1 Newton is equal to 1 kilogram times meter per second squared, which is 1. So that's the unit. You can pause this part and complete your notes. And please be aware that I'm mentioning some important words that you will also have to put in your notes. That doesn't mean that I did not wrote it in here. It may not be asked in your quiz or your assessment. Since force is a physical quantity and it is a vector quantity, therefore it has to have a magnitude in direction, then we will have to draw forces using an arrow. So at the bottom is a sample of the arrow. The arrow has its parts. So you have the arrowhead, which tells you the direction. So right now this force is heading towards the left, so it is in a positive direction. The dot here, this tail, represents the origin. So where did it started? Okay, so where did the object started its motion? And this represent the length of the arrow. The length of the arrow represents the magnitude. So that means it should have the size or number plus the direction. So for example, I would say, so if we just say 1 Newton, it's technically not force unless we put downward. Okay, in this case, leftward. So 1 Newton to the left, or you could just write down 1 Newton. So that's understood that it's positive. Could either be moving north or could either be moving left if you just wrote this. But if you put leftward, that's pretty understood that you're talking about this arrow. So that's how you represent a force. But let's identify forces first. Before drawing a particular force, let's identify what are the type of forces. And make sure you also write all this thing in your notes. I need to see that you have this notes. So let's recognize some forces. So what are some forces that we know? So go pause your video and then come up with a list of forces that you know. You probably will have force of air there. But what other forces do you know? You probably will mention the force of gravity, right? So what else do you know? That's what we're going to find out. There are several other forces that I have not included in this concepts in this video because we are not gonna cover them, but that doesn't mean they are not forces. So I just put the ones that I know it's gonna be part of your learning. It's gonna be part of the assessment of your learning. So let's recognize some force. Let's start with the weight. So the weight or force of gravity is a type of force due to gravity. Weight is not mass. So mass is the amount of matter. How many particles are there? Weight is related to mass and the acceleration due to gravity. So that's technically not the same. And it is equal to force of gravity, which you could write as F sub grav or F sub lowercase g. So this is what I was telling you. You're going to write the subscript of the type of force. So the first one here is the force of gravity. So how do I draw this? So force of gravity points downward. It's the weight of the object. So if I use a force vector arrow, and I could label this as force of gravity. So that's how would I draw that. Or I could choose W, which is the weight. So that's how I will draw force of gravity. Can I draw force of gravity sideways? Is that correct? No, it is not. Because it says here, force of gravity is always directed downward towards the center of the earth or any other planet or any object that has gravitational force. So that is not how you draw it. It's always pointing downward. Definitely not going up. So those are wrong. Another type of force is called normal force. Okay? Take note, normal, not natural. This is a common mistake for some that it's a natural force. No, naturally it exists, but normal force, because it is exerting on the object that are normally in contact. So normal force is written as F sub n, uppercase N, subscript n. So let's take a look at this. A book. So let me draw a book. So there is a book that is resting on a table. So you have the table there. And there is a normal force because there's contact. It's in contact. So normal force is usually written perpendicular. So perpendicular. It is perpendicular to the contact surface. Okay, so it should be perpendicular. So I'm gonna draw normal force. The normal force is that it is an upward force upon the book. So I'm gonna put a dot in here between the table and the book. I'm gonna put it in the center because it exists right in the center of the object. So I'm gonna draw that. I'm gonna label it F sub n. So I have a normal force. So that is how you draw a normal force. Another type of force is called spring force. So if I have a cart and I attach a spring that is fixed to a wall, and I kind of like push and pull this cart, the spring force will act a force that will keep this object from going back and forth. So there is compression, there is relaxation of the spring. So I'm gonna write down a spring force for this as F sub S. So that is how the spring force. If I have an object that is hanging from a spring, then I will just write down F sub S, spring force. Or I can write the word if I want. Another type of force is air resistance. So this is a special type of friction force. So you can either write F sub air or lowercase f that represent friction. So in physics, we write lowercase to represent friction. And then you put a subscript to what type of friction it is. Just like here, it's air. So if you are driving a car, and you're speeding up at 80 miles per hour, the air exists an air resistance against you. So there is air resistance. There's a force of air. You can just draw one, you can draw several to represent it. This would cause your object to resist such, and it might slow down your speed. But then most of the problems we are going to encounter will ignore air resistance. So we will kind of like ignore it because it's kind of like negligible for some of the problems that we're going to be dealing with. Another type of force is called tension force. So that's how you write it. So you can write down F sub tens or just uppercase T. So if I have a picture frame and I hang it onto the wall, with a string, not a spring, a cable or a rope. It's right here. Fix it into a ceiling or maybe just a wall, then there is a tension force here. Or I can write down F sub tens or uppercase T to represent that. Another type of force is called applied force. So when you have a box or a crate and you are pushing the crate in a leftward direction, you are putting an applied force. And if there is friction between the crate and the floor, then you could draw a friction which is opposing the applied force, as like that. Or we can ignore it, then you do not need to draw it. If we consider air, then there must be another friction of air. Or we can just ignore it and you just only have this. So those are the different types of force that we look into. So let's practice. Let's take a look at this picture and determine what type of forces are present. So pause your video and try identifying whether this type of forces are present or not. And we will try to explain why. So this should be your answer. So if you did not get everything right, then this may be a best time to focus your attention on why. So in this case, the car is on Earth. Therefore, we will assume that objects are acted upon by the force of gravity. So force of gravity acts on all objects on Earth. Okay, that's our assumption. And the object is attracted to the Earth. Is there a spring? Okay, you might argue that, hey, the shocks are in there, but we're looking at the car as the entire system in here. So there is none. There is no spring touching the object, and there's no spring force in here. Tension. Is there tension in there? So it's absent. There are no ropes or string attached. No springs to touching the object. So no strings, cable that is taught on the object. What about normal force? The tires are in contact with the ground. So there is a normal force. Even if the car is moving, the car is in contact with the ground. We did not ignore friction, so there is no mention that we will kind of like ignore friction. We will add it. So that's one kind of like rule. If it is not mentioned, we assume it's present. So there is friction when the wheels are skidding or rolling on the ground. There is no mention that we are going to ignore air resistance, so we will consider that it's part of it. So the object is moving through air. It is moving through air, so we include it. So let's have another one. So pause your video and look at all the type of forces that might be present or absent in this case. So this is pretty much the same as the first example, because it looks like it's just a different object, but the situation is technically almost the same. So there is no spring force that is touching the object. There is no rope that is started to it unless somebody's pulling it, but there's none. So we're not gonna worry about that. There is normal force because it's in contact again with the snow or any object. There's friction even if it's less. There's air resistance because it's moving through air still. So those should be your answer. What about this one? So a bucket of water is attached by a rope, is being pulled out of a well. So let's take a look at what are the forces involved here. So pause it and give yourself some time to think. Did you answer it right? So there's always force of gravity acting on it. There's no spring attached to it. So this is X. What about tension? Oh, there is a cable in here, so there is a tension. So there is force of gravity because the object has weight. Is there normal force? There is no object that are in contact that is stable, so this is absent. There is no object moving that is across a surface in here. You might argue that there might be friction between the rope and the hand, but that's a different scenario there. We're just looking at this being pulled, so that is absent. This one will move through air, so this should be present. And that should be it. Go ahead, go back to Google Classroom and take a quick assessment of your understanding about recognizing forces, or give yourself some review.